Good morning, favorites. It's Miss Hill. Happy Tuesday. I just wanted to come on here and do a quick screencast about how to solve problems from 6.4. A bunch of you have let me know that this section's a little bit challenging, so let's take a minute to review the notes and then I'll do some practice problems with you. So in the 6.4 video, they talked a lot about the difference between congruent and similar. So congruent means exactly the same. It would be like having two identical twins. So they're the same size, they're the same shape, they look like they've just been put on a copy machine and made an exact copy of them. Similar is a little different. So similar would be that they have the same shape. So it would be like two triangles that are drawn exactly the same in terms of their shape, but maybe they were put on a copy machine and one of them was shrunk down, so it's a smaller version of the original one. So when I'm thinking about the difference between congruent and similar, I'm just thinking about the actual size. So both of them are exactly the same shape, but with similar, maybe they were shrunk or expanded so that they're a larger or a smaller version. I'm going to use that idea of congruent and similar to solve problems with triangles. So this is not the worksheet that I posted for you. This is actually a different version of it. So I'm going to use this version to talk about how I use similarities and congruency to compare triangles. Okay. So in this example, it says triangle ABC is similar, so not exactly the same, right? It's been either shrunk or blown up. It is similar to triangle YPL. They want us to list the corresponding sides and corresponding angles. So what's important about this is I'm identifying the sides that are going to have a relationship to each other. So if I'm asking about side AB, that's this side right here. And what I want to look for is what's that exact same side on the other triangle. So the other side that's in exactly the same spot is side YP. And I put that little line above it just to show that it's a side. That's the symbol for side. So notice that AB is 12 and YP is 8. So that's not the same, but it's in the same location. They're in the same spot of the triangle. The next one says BC. So BC is this side here. The other side in the other triangle that's in that same spot is side PL. And then lastly, if I look at CA, that's this side here. The side that's in the exact same spot is side LY. Now notice I didn't write YL. I want to use the same format as the original side. Now it's asking me to compare the angles. So what other angle is in the same position as angle A? Here's angle A over here in this little corner. Well, on the other triangle, the angle that's in that exact same spot is angle Y. If I look at angle B, the angle that's in exactly the same spot as B, and I can put two little rings around it, would be angle P. Notice that they both say 90 degrees. That's because they are corresponding. And then I could put three rings around C and show that it is corresponding with L. Notice that the pairs that I said are corresponding have the exact same measurement. So I'm going to use that information now to solve some proportions. So they want me to solve for X. A proportion is just a ratio showing what's related to each other. So if I'm going to compare this first triangle with the second triangle, I want to write some corresponding sides. So this side that is 10 corresponds with this side that is 20. So I'm going to say 10 corresponds with 20. And I'm going to do the same thing on the other side. So X corresponds with 6. So I've written a little proportion that just shows me what's related to each other. And to solve that, you're going to Go back in the recesses of your mind. You're going to do some cross multiplication. So I'm going to multiply 20 times x. And I'm going to multiply 10 times 6. To solve for x, I'm going to divide by 20. These cancel, and x is going to give me 3. Now think about, does that make sense? The relationship between 10 and 20, right? So to get from 10 to 20, I had to multiply by 2. So does it make sense if I solved this for 3? Does it make sense that I would go from 3 to 6, those corresponding sides? It does, because I'd multiply 3 times 2, and that would give me 6. Okay, so now I'm going to do another example, and this one's a little bit more complicated because it's got 2 variables. But still, all I want to do is find the sides that correspond and then create some proportions. So if I'm going to try to solve for x, what other side corresponds with x? Well, the side that's in exactly the same spot, as x is 20. So x is in proportion to 20, or is corresponding to 20, in the same way that 12.8 is corresponding with 16. So 12.8 and 16 are in exactly the same spot. Now, one thing to remember here and notice is that the top numbers, or my numerators, came from this first triangle. My bottom numbers, or my denominators, came from the second triangle. I want to keep that pattern the same every time I write a new part of my proportion. Okay, so again, I'm still going to do the same thing here where I'm going to cross multiply, and this would be a totally okay time to get your calculator out since you've got a decimal to handle. X times 16 is going to give me 16x. And then on my calculator, if I do 20 times 12.8, that's going to give me 256. To solve for x, I'm going to divide by 16. When I do that, these 16s are going to cancel. 256 divided by 16 on my calculator is going to give me 16. Now it's giving me another set because now it wants me to solve for y. So what I want to do is I want to look at y and I want to think about, what does y relate to? Well, y is in the same spot as 10. So I'm going to say that y is in proportion to 10. And then I can still use the same comparison here. So I can use 12.8 is compared to 16. The same proportion I used to compare when I was solving for x. I'm going to cross multiply just like before. Y times 16 gives me 16y. 10 times 12.8 just moves my decimal, so that gives me 128. Now I'm going to divide by 16 to solve for y. Totally okay to use that calculator on 128 divided by 16 gives me 8. So then here in the box, that's just a space for me to write my answer. So x was 16 and y was 8. I hope that helps. Again, these were examples from a different worksheet. So go ahead and try lesson 6.4, the practice worksheet, which is the one that I posted for you on Google Classroom. If you have any questions, I'm going to be on Google Hangout today, Tuesday, and tomorrow, Wednesday, from 1:30 to 3 p.m. You can join me there. I'll post the link about 1 o'clock or so. I'll send a reminder that I'll be on there. So come join me, come ask a question. We can do a worksheet together. I could just see your wonderful faces and say hello. I would love it. Have a great rest of your day, guys. Bye. Miss you.